We are on the set operations, and these are the operations that are performed on sets. And we've defined about 4 main operations that you can do under set theory. The first one being the union, and that is where you are looking for the elements that are in all the sets under discussion. If you are dealing with 2 sets, when you apply the union operation, you are looking for the elements that are in both the sets that you have. If you are looking for the intersection between 2 sets, you are looking now for the common elements, the elements that are in the first set and the element that is also in the second set. Remember, this has to be a common element. If there is a 2, there is only 2 in the first set and only 2 in the second set. That implies that the intersection or the third set is going to contain the element 2. And the third operation we talked about is the complement of a set. And the complement of a set is going to be the second set. Remember, by complement, you are dealing with one set. It can be set A. So if you say the complement of set A, you are looking for the elements that are not in set A, but outside, but in the universal set. The third or the fourth operation is the difference of 2 sets. Remember, and I'll keep on emphasizing on this one. When we say the difference between 2 sets, we are not saying the difference of the elements. No. What we are looking for is an element that is in the first set, and it is also in the second set's complement. So this is what is denoted. This set is denoted by A minus B. So its element is going to be X that belongs to A and X that belongs to B complement. So quickly we are going to look at the examples using these set operations. So the first example is if E, remember E denotes the universal set. So if E is 0, 1, 2, 3, dash, dash to 10. So this implies that you have the elements from 0 to 10 in the universal set. And you have set A to be 2, 4, 6, 8, 10. Find a complement. Remember, by definition of a complement, we said it is an element that is not in A, but in the universal set. So to do this quickly and in a way you are going to understand it, you can first begin by showing what your universal set is. Under the universal set, we are only looking for one set, which is called set A. And we've been told that in set A, you only have a 2, 4, 6, 8, and 10. You're having 5 elements. That means the rest of the elements are in the universal set. So the elements under discussion, you're starting from a 0 all the way to 10. So if 0 is not in A, it should be in the universal set. The element 1 is not also in A, it should be in the universal. So you have 0, 1, 3, you have 5, you have 7, you also have 9. So when we say find a complement, we are looking for this set. So these are the elements that are not in A. So you can remove your set A here. Then the rest of the element X belongs to U. So 3 belongs to U but does not belong to A. 1 belongs to U but does not belong to A. Therefore, your A complement, your A prime, is going to be the elements 0, 1, 3, 5, 7, and 9. This is your set that you are looking for. Okay, now go to the second example where we are saying if B is 0, 2, 4, and B complement is 1, 3, 5. Find E. Remember, E is your universal set. And we, by definition of universal set, we mean all the elements that are under discussion. Again, you can begin by showing your Venn diagram. And we only have one set in the Venn diagram that we're talking about, and this is set B. And under set B, we have the elements 0, 2, 4. Then B complement. This B complement, it implies that the elements that are not in B, and if they're not in B, they are in the universal set. So outside B, you have 1, you have a 3, you also have a 5. So what is your universal set? Don't say a 1, 3, and 5 is your universal set, no. All the elements under discussion is your universal set. Therefore, you say that your E is equal to, so you have a 0, you have 1, 2, 3, 4, 5. 6 elements are the elements that are under discussion. That is your universal set. We can now look at the last example. Number 3, so note that this is supposed to be the universal set. And what we've been given is the universal set and the C complement. And we've been told to find the elements that are in C, or to define set C. So we can always begin with the Venn diagram. We only have one set under consideration, which is set C. So the elements we've been given is the C complement and universal. So C complement, these are the elements that are outside set C. So outside set C, you have 1, you have a 3, you also have a 5. Meaning the remaining elements are going to be inside set C. But the remaining elements, you have a 0, you have a 1, you have a 2. What else? A 1, we already have 1 outside. So this is not a 1. So you have a 0, you have a 2, you have a 4. This is a 4. You also have a 6. So these are the elements that you have under set C. So set C is going to be a 0, a 2, a 4, and a 6. So for now, these are the examples we can look at the end of the set theory. We are going to look at more practical questions where we are going to pick a tutorial sheet that we are going to look at some of the challenging questions.